Hi guys, welcome to another MIAP video. Today what I'm going to do is I'm going to go through test 5 and I'm going to go over R1, R2, R4, R5, and R8. So please feel free to forward through questions that you don't need to watch, and feel free to rewind questions that you want to see over and over again. All right, so here we go. Hi folks, so here it is. Here is your test, chapter 5 mostly. We're going to go over R1, interpreting relations first, and we're going to go through the test just as you would be writing it, and I'm going to explain it as I go. So hopefully if you have any questions about what happened or what to do for a question, it'll be answered here. All right, so let's get started. Okay. So our first question is Lenore. It's about Lenore. She's going to go for a walk. And let's see where she ends up, okay? The first thing it says that Lenora starts her 3.5 kilometer walk home from school. So she is going towards her house. And if you notice right here, this says distance from home. So if she's 3.5 kilometers away from home right now, that means that she starts right there. Okay? Now, after walking 1 kilometer in 20 minutes, now notice down here in the clock, this is where 20 minutes would be. So then if she starts at 3.5 kilometers and goes 1 kilometer, then she ends up at 2.5 kilometers. Now that's our first kind of place, our first place where our first point, our first line that we're going to connect here. Okay. Now after that, a good idea is to connect the two dots with a straight line. Hopefully you have a ruler. I don't. I just realized I didn't have a ruler. She stops to talk to her friend, and she talks for 10 minutes, okay? So she stopped and she's talking, she's not walking. So that means from here to here, she doesn't move at all. So her position stays exactly the same, all right? And now that's where she is stopping and talking to her friend. She continues to walk at the same pace, which means, notice how we have one square, one for one, one down, one over, one down, one over. She does the same thing, and it says 15 minutes later. So she does that walk for 15 minutes, okay? So now we're here at 45, so let's connect that. She stops for 5 minutes to rest. So between here and here, that's 5 minutes. She doesn't change her position. And she starts walking at the same pace again after 15 minutes. So she's walking for the same pace again. And after 15 minutes, that means that she's walked for 15 minutes at that same pace. So we're at 65 minutes now. Okay. After 15 minutes of walking at that same pace, she now runs for 5 minutes until she's at home. So here to here is 5 minutes. Now she runs. So that means she goes very quickly from 1 kilometer. Okay. So that's our first question done. Now the next question right here looks at the volume of gas in a car as a function of time. Describe what's happening in each of the following line segments. All right, so right here, this is E to F. What's happening? Well, you notice this is volume of gas. The volume of gas is not changing. So when does the volume of gas in your car not change? Well, that's when your car is not running or when your car is stopped. So let's say, for example, they maybe stopped for lunch. for 1 hour. All right. So from here to here, that was 1 hour. About right. Now, if you notice right here, what they did just before that, that's actually this question right here. So that's DE. So why don't we just look at DE for a second and notice what is happening there. So let me just slide that over. Okay, so right here in DE, let's see this line. So that's this line right here. What do you notice happening? Okay, so the volume of our gas was pretty much at 0, and then all of a sudden, very quickly, it reaches around 70 liters. So how does your gas tank fill up that quickly? Well, they filled their tank up with gas. So they're at a gas station and they filled up with fuel. So filled tank with fuel at the gas station. So this gives us a little bit more insight about what is happening here, right? And notice that's right after, that's when they actually stopped for about an hour. So here they filled up with gas and gas. Okay, so AB. Now what's happening in AB? That is, let me get a different color. That is right here. So we've got AB. The tank is slowly decreasing. What do you think they're doing? Well, time from start of journey. Well, that's probably because they're driving. They're driving their car and they're using the gas in their tank. So they used 30 liters in 3 hours. So they're driving. Okay, so that's pretty much what we're looking for, a description of what's going on, each line segment. Let's go on to the next question. All right, so right here we have this graph. It's made of dots. Notice that these are not connected. It's showing the cost of parking as a function of time. So you need to determine the domain and the range of a graph. And we talked about the domain being our independent variable here. So this stuff down here, so time, that's going to be our domain. And cost is going to be, those are the elements of our range. All right. Now, when you're parking, this parking meter or parking parkade doesn't charge you for exactly, to the minute of where you're parking or how long you're parking, I should say. It charges you in increments. So you park for 30 minutes, you get charged $1. You park for 45 minutes, you get charged $1.50. You park for 70 minutes, they charge you $2.50. So they don't care if you're staying there for an hour exactly. They're not going to charge you $2 because there's no dot there. Okay. So the domain, what we're looking for is we're looking for you to list all the elements of X. So 30, 45, 75, 90, and 120 are all the elements of X. So if you just kind of look straight down, that's what we're going for. Read off that number there. Okay. That's our domain. Now for our range, we are looking at the Y values. Okay. So here, I'm going to do it in red. Right here for this first element, if you look over here, what number do you see? You see 1. So our range for Y is 1. And then here we've got, this is 1.5, so 1.5. And right here we've got 2.5. And right here, we've got 3. And this is 4. So those are our elements of our domain and our range. Okay. Next question is a graph, and it's showing the free fall speed of a skydiver as a function of time. What is the domain and range of the graph? Okay, so this graph looks different because the lines are all connected, and you basically want to see where it starts. So right here, our domain is our time, and it starts right at 0, and it goes all the way towards 60, now let's say that's 62.5 or 63. I mean, I'm not going to be so picky about that. So that's our domain. And the reason we write it this way is because all the values in between, they exist. So we've got a line connecting all of my values. So I'm going to say, 62.5 as my domain. And you could have your, fancy bracket there. Okay. Now our range is the same idea. It's just on the y. So it's right here. That's what we're going to look at. And it starts at 0 and it goes up to, and what's the highest value that we're reading off here? This is going to be 140. Okay, because this line only goes up that high, so I don't have any y values over here. I don't have any y values below. The graph doesn't extend that far anyhow. So then my range is going to be y such that y is in between 0 and 140. Okay, now last question on this outcome here. It says a relation is given by a set of ordered pairs. Now, here's the set of ordered pairs. Represent this relation using an arrow diagram. Okay, so if you recall arrow diagrams, that is 2 ovals we had. One of them had the x values, 1, 2, 4, and 7. So right there. Okay. And the other one had the y values. Now, what do you notice about the y values? Huh, interesting. They're all 3. So you only need to write one element. There's really only one element in that other oval, right? Okay, so now here's our arrow diagram. We need an arrow going from each element in the x going to the same element, and you need to have arrowheads there, okay, showing that it's all going towards 3. So there's your arrow diagram. Okay, now this is R2. Okay, so this is R2. And this question is asking which of these graphs represents a function? Circle. So, well, and you know what? I'm going to actually answer 7 before I answer 6 because it explains in words why you selected the graph in question 6. And I'm going to answer 7 at the same time, I guess. So if you recall the definition of a function, we use the vertical line test, which if we could draw a vertical line through each value here, we notice that we only cross one point at any given time over here. So if we use the vertical line test here, we're going to cross all the elements. If we use the vertical line test here, that one's okay, that one's okay, but right here, this is a problem, okay? And so is this one. This is a problem because I've actually went through 2 different points, and that's not allowed. Same thing here and here. Well, actually, they're all problems because they all go through 2 or more points. And, well, here. All right, so the answer is that one. And why is that my answer? Well, that's because using the vertical line test, we see that we see only 1 point being crossed at a time. Okay, so there can only be one y value for every x value. So only one y value for each x value. And I guess really this is kind of a better definition than that stuff I wrote up there. Okay, now does the following set of ordered pairs represent a function? Why or why not? Okay, so number 8, we want you to notice, again, the exact same thing here, only one y value for each x value. So what do you notice here? We have this point and this point. I've got 1, 2 and 1, 3. Well, I have 2 different y values for one x value. That's not allowed. All right, so that's a problem. If we were to graph these points on a grid, just real quick, if I take this point here, 1 and then 2, 2 and 3, 3 and 4, and then this point 1 and 3, I'm going to notice that these 2 points right here, these 2 points here are going to fail the vertical line test. Okay, so this point again, because it was off the screen, is 1, 2. This point is 2, 3. This is 3, 4, and this one is 1, 3. So again, it's this point and this point that make the test fail. So this is not a function. Okay, so let's continue with R2. Question 9 says, a relation contains 2 elements in the domain and 4 elements in the range. Can this relation be a function? Justify your answer. Okay, so here's one example. Here is an example. If we were to look at some points on a graph, our domain would be here, and our range would be here, okay? Now, it's saying it has 2 elements in the domain, so you can only have 2 values in the domain, let's say there and there, and 4 elements in the range. So let's say we've got 1, 2, 3, 4 elements in the range. So if I were to set this up somehow, I could have a point here and a point here, and then maybe a point here and a point here. So now notice the domain, I've got 2 points this way, right? And that allows me to have, I've only got one kind of element in the domain. It's the value right here, whatever it is. And then if you look this way, it's got 2 elements in the range. And same for this one. And if you notice, if you relate it to the question previously, you're going to see that this actually fails the vertical line test. So this is not going to be a function. No, this is not. This cannot be a function. All right. Number 10 says, which of these graphs represents a function? Well, this is pretty much the vertical line test again, folks. If we look right here, we're going to notice that you've got this is the part that kind of makes the vertical line test fail. So that's not one. Anywhere for this one, because if we draw a vertical line, it's going to hit twice, pretty much anywhere. And so that's not a function. And same thing with this circle here, it's going to hit twice. So this is not a function. This is our only choice left. And no matter where you draw a vertical line on this, it only ever crosses this graph once. Okay, so this one is a function. Okay, all right. Now, next one is, so here, this is R4, representing linear relations, and it's just asking whether they are linear or not. Okay, so here we notice it's actually equation of a linear equation. Notice the exponent on the x, there isn't one, so it means that it's just a 1. So that's how we know that that's linear. This has an exponent of x squared. That makes it a quadratic. That is not linear. This is kind of what this graph looks like. This equation has an x squared in it right here. And we see that, well, it's clearly going this way, right? That looks nothing like a straight line. That is not linear. Right here, if we look at this, we notice that these go up by 2 until here. Okay, problem. Let's see. Okay, well, let's see if this goes up by 2. That goes up by 2. That goes up by 2, 4, 8. Okay, so this kind of jumps 4 more from here. Notice the difference from there to there is 4, and from here to here, it was 2. So there's all sorts of strange things happening here. So this one is not linear. And we've got a professional photographer charges $20 for a photo session plus $1 for every photo taken. So this equation is actually going to look like y equals 20 plus 1x, and that is linear. The height of an object falling to Earth, well, if you notice right here, you've got an x squared. This is, or sorry, a t squared, I should say. That is not linear. Okay. Now, this question here says the set of ordered pair represents a linear relation. Determine the value of n. Okay, so how are we going to do this question? Well, why don't we figure out how it goes up, and then we can determine some more information. Okay, so for this question, your best bet is to make a little t-chart perhaps. So here I'm going to have x values, and then I'm going to put the y values corresponding, and -2, 3.5, 9, and 20 are my x values, and the corresponding y's are -1, 10, 21, 32, and 43. Okay, so what I want to notice is what each goes up by. So if I look at this here, how do I get from -2 to 3.5? Well, I add 5.5. How do I get from 3.5 to 9? Well, I'm going to add 5.5. Okay, well, then that must mean that I add 5.5 to get to n. So then this is going to be 9 plus 5.5. All right, so n is 14.5. Let's double check. 14.5 plus 5.5, it equals 20. I'm good. And just to be sure that this is a linear relation, we can just kind of look to make sure that this also goes up by the same amount. And you see here that I add 11 each time to get to the next value. Very exciting. Okay. That was our 4. Now our 5 Our 5 shows a graph, and in our 5, we want to look at characteristics of linear equations. So here we've got a graph showing the distance d kilometers right here from Beijing, China to Edmonton, Alberta as a function of flying time and t hours. All right, so determine the vertical intercept. Now, vertical means line going straight up and down, and intercept means it goes through the axis. So here, this is our vertical intercept. So our vertical intercept is 9,000. Determine the rate of change. Okay, so this is our rise over our run, which is also our distance over our time. So our change in distance over our change in time. All right, and that is going to be, now you notice how this is going down. This is a slope going downwards. So we go down 9,000 and we go to the right 12 hours. So our rate of change is negative. It's negative because we're going backwards, basically. We're going back because the graph says from Beijing to Edmonton. So this here is Edmonton down here. That's when we get to Edmonton. That's when you're in Beijing going towards Edmonton. All right. Domain and range. Okay, so the domain we want to write as, that's our time. That's here. This is our domain. And the values that we see here, they start at 0 and they end at 12. And all the values in between are included. So I can simply write x such that it's between 0 and 12. And our range is right over here. So it starts at 0 and it goes all the way up to 9,000, and all the values in between are included. So that's our y value, goes from 0 to 9,000. Okay, so our domain, it's our time, and our range is the distance in kilometers. Okay. Now for 1 point, part D says, what is the distance to Edmonton when the plane has been flying for 5 hours? This is when we have to look at our graph and we have to read some information off of it. So you want to find 5 hours. So 5 hours is going to be right over here. So it's between the 4 and the 6. And then we want to go straight, okay, try to go a little straighter than me. You want to go straight up, hit this line, and then read the number right here. So it's just above the 5,000. It's not quite, it's not near the 5,500 mark. So it's going to be slightly less than that point right there. So I'm going to say, I'm going to estimate it's around 5,250 kilometers. And the last question says, how many hours has the plane been flying when the distance to Edmonton is 6,500 kilometers? So that means we want to be looking right here, 6,500 kilometers, and I'm just going to slide that down. 6,500 kilometers is right there. Hit this line right here, and then go straight down from there. And note that it is, well, there's my 3 marks, so it's around 3.5 hours, okay? Around 3.5 hours. Okay? So that's our 5, and we've got, I think, one more question in our 5. And this question says, sketch a graph of the, let's keep it on Here, sketch the graph of the linear function by plotting the x and y intercepts. Okay. So now we know a couple of things about x and y intercepts. We know for x-intercepts, this is when our y value equals 0. And to find that, what we do is we take this, f of x equals 2x minus 4, and we set this to 0, and we write 0 equals 2x minus 4, and we solve for x. So then we've got, so add 4 on both sides, so we have 4 equals 2x, divide by 2, and we've got x equals 2. So our x-intercept is at x equals 2, so find that on your graph. So this is 0, 1, 2, so let's call that 2. We'll put a big dot right there. Write down your answer over here. And then let's label this point so it's 2, 0. All right, just so we all know what we're talking about. And our y-intercept, I'm going to do that in green just because I can. Our y-intercept is when, hi Noah, can you be quiet please? Okay, so this is when, okay, I lost my train of thought here. X is equal to 0. Okay, so here for our y-intercept, what we want to do is we want to set x equal to 0 and then solve for the y. So here we've got f of x equals 2x minus 4. So let's write y equals 2 and then times 0 minus 4. Well, you notice right here that this is 0. So we end up with y equals negative 4. So then over here we want to find negative 4. So 1, 2, 3, 4 in the negative. Label this point so it's negative 4, 0. And then if we connect these two dots, this is going to be our line. And we can actually continue through the pattern, make nice arrow, and that's our graph. So our y-intercept is negative 4, and that's how you do that one. Okay. Now, our last outcome, this is our 8, and this is the function notation business. So here, we're asking to find f of 5. Well, over here we have f of x equals 3x minus 4. So notice right here how we've got an x, but right here we have a 5. So basically, what you need to do is you need to take this equation and you need to notice that the difference is they've put a 5 there. So what you have to do is you have to put a 5 where you once saw an x. Okay? Now you have 3 times 5 minus 4, and this is what you need to compute. So 3 times 5 is 15 minus 4. 15 minus 4 is 11. So the answer to this question is f of 5 is equal to 11. And the same thing to find f of 1. So f of 1, we have our f of x is 3x minus 4. We want f of 1, which means that we replace the x with 1 and compute. So 3 minus 4 equals negative 1. So we've got f of 1 equals negative 1. And that's our answer there. Now this part here, the next one, says f of t is equal to 5. What is t? Okay, really what's happening here is we still have our f of x, okay? We still have our f of x equals 3x minus 4. If I change it to f of t, notice the only thing, what I do here is I replace this x with a t. I'm going to replace this x right here with a t as well. So now I have 3 times t minus 4. Okay, now the question says if f of t equals 5, find t. So since this is f of t, if f of t is equal to 5, then I could set up this equation right here. So 5 equals 3t minus 4. And then from here, I can solve for t. So add 4 on both sides. 9 equals 3t. Divide 3 on both sides. And I end up with t equals 9 over 3. And that's actually going to reduce to 3. So we end up with t is equal to 3. And the last question on this test, I need to make sure I'm staying in the lines. This is a graph of the function f of x equals 2x plus 1. Determine the range value when the domain value is 2. So that means find y when x is equal to 2. So right here, this is x is equal to 2. So draw a line until you hit the line of the graph here. We've got, and we look over, and what number do we have here? Well, since it goes 1, 2, 3, 4, this must be 5. Okay, so y equals 5 when x equals 2. So the range value equals 5 when the domain is 2. Okay, so there's the entire test. I hope this was valuable for you. I hope you got something out of it. I hope it answered some of your questions. And please feel free to rewind and rewatch parts that you particularly found entertaining. Okay, thanks for coming out.